All right, so in this video, we'll continue our conversation. Same exact problem, but as promised, now we're going to go up to 4 rectangles. And this will, again, I'm really hoping will make it a lot more sense as you start to see more rectangles take form. So here's our same function there. We know this is at 1. And if we know we want 4 rectangles, halfway was 1/2, right? So that'll give us 2 rectangles. Then halfway there would be a 1/4 and then a 3/4. So for the upper sum, again, this is going to be the overestimate. If I come all the way up and this comes over the top as it is, I'm now overshooting it, and therefore it's going to be a bigger number than it actually should be. Same thing here. I'm just going to go ahead and move over and down, over and down, and then over and down. So those are my 4 rectangles. And by now, I'm guessing you're starting to see that, okay, the more that I have, the closer I'm going to be to the actual area, because there's not going to be so many overshoots or undershoots. All right, so base times height. Our bases are now going to be 1/4, and we'll need our heights. So for our heights, that's going to be this guy here, this guy here, this guy here, and this guy here. The first one is going to be f of 0. The second one from right here, that's going to be f of 1/4. The next one would be right there, and that's going to be f of 1/2. And the last one, our height, would be f of 3/4. All right, so now it's a matter of, again, just putting together the area. So area, base of a 1/4 now, not a half anymore, 1/4 since we have 4 rectangles, times the height of f of 0 plus base of a 1/4 times the height of f of 1/4. So that was this one right here. So base of a 1/4 and the height right there of f of 1/4. Then we'll have plus a 1/4 f of 1/2 plus a 1/4 f of 3/4. When all is said and done there, and again, you can plug the numbers, you can plug this, the 0 into the function, the 1/4 into the function, etc., etc. I'm not going to waste time doing that on the video. When all is said and done there, we get 0.78125. And so for 4 rectangles, this would be the upper sum. So now I think I left myself enough room to do the lower sum on the same screen so that you can even see and compare maybe a little bit. So if I draw the same similar picture, there's my 1. I still want there to be 4 rectangles. So here's a 1/2, a 1/4, and a 3/4. But now, since we're on the lower side, the underestimate, this is how the rectangles would be shaped. And you're hopefully starting to see again how it's an underestimate. And hopefully, especially, you're also seeing this very last one here that's going to sit there. It's with two rectangles on the last problem, it was very difficult to see, but with 4, it's a little more clear, I believe, that you're going to have this value right here, the 0 value, be a part of it. So as far as the heights go now, our first one here would be f of 1/4. The next one, as I come over, that's going to be our f of 1/2. This lower one now is f of 3/4. And finally, the bottom one, that's that f of 1 that I mentioned before that goes to 0. All right, so area, we've got our base 1/4 and our height, f of 1/4, plus base of 1/4 times height, f of 1/2, plus base of 1/4 times f of 3/4, plus base of a 1/4 and a height of f of 1. So when all's said and done there, that gives us 0.53125, which is, as mentioned before, our lower sum. And that area is still going to sit between there, right? One's an overestimate, one's an underestimate. And so when it comes to to deciding what to do and deciding what to use, my math lab will be very specific. I'll be very specific in the things that I give you as well, but understanding that our goal is to construct these rectangles, which is very easy then to find the area of, then sum up all of the areas, with the goal being as many rectangles as possible. That's where we're heading with all this. And so this is a really good section of just basic geometry, if you will, to kind of connect everything together. Now, before I move on to the last part, I want to specify something that is sometimes a mistaken idea early on in a particular section like this. The words left hand, right hand, endpoint, stuff like that, we haven't used that yet, okay? That's going to come down the road. I understand that if you're looking at these rectangles, you might be thinking to yourself, why don't you just call this the right hand point or the left hand point? We will get to all that later. The names that we're using, the upper and the lower, are very, very specific to what we're doing. So please understand, if I gave you a different function, for instance, the upper might be a different endpoint on the rectangle. So keep that in mind as you do the homework, okay? The right hand, left hand endpoints will come into play later, but we're not to that point just yet. So now I am going to go ahead and clear the screen. I'm going to put up the same thing. We're going to use a different approximation, and then we'll see where that takes us. Okay, so for the last example, now we're going to use the midpoint of two rectangles. So we're going to go back to two rectangles. We're going to look at the midpoints of those and see how that approximation works for us. Since we're going two rectangles, I'm going to go back to the 1/2 like I have. And that 1/2 is going to be one of the sides or of both of my rectangles. But since I'm going to use this midpoint, this guy here is going to be our 1/4. And if I come straight up from here, that's the point that we're going to use. So I want to make sure I pick the correct height that goes through that to give me that rectangle. This is sometimes a better approximation because you've got a little bit over and you got a little bit under. Same thing on the other rectangle. The 1/2 will be one of my sides, but the midpoint here of 3/4 coming up gives me a height of my rectangle right there. So the overall base of my rectangle is still going to be 1/2, but my heights now are going to be f of 1/4 for the first one, and then f of 3/4 for the second one. Okay, so our area, a base of 1/2, a height of f of 1/4, plus a base of 1/2, a height of f of 3/4. This in a calculator gives us 0.6875. And if you go back and you look at just all of the pictures that we've drawn, this one looks to be about the best approximation, and it actually is. The actual area under this curve on the interval 0 to 1 is 0.667. And so that got us pretty darn close to what it actually was, and that's only with two rectangles. If we continue to increase the rectangles, we're going to get closer and closer to this number right here. So again, in closing this section out, there's some new terminology with the upper sum, the lower sum. The function is dictating where those endpoints are going to be, not any other terminology, but the function itself determines that. And then from there, we've talked about multiple rectangles and how to go about constructing them to get the sum of areas that you're looking for.